Hello, in this video I will review the answers to the extra credit quiz review. Number 1 states the following. An Australian biologist is comparing the variances in lifespans of two types of related marsupials, wombats and koala bears. She claims that the variance for the lifespan of a wild wombat is greater than the variance of the lifespan for a wild koala bear. The data she collected is provided below, and I just want to insert here that the units for the data is years. We want to test her claim using alpha 0.05. So we're given the two standard deviations and the two sample sizes. Since we're comparing variances, we are performing an F-test. We state the claim. So the claim is that since standard deviation 1 is larger than standard deviation 2, we assign subscript 1 to the data involving the wombats. So the claim is that variance for the lifespans of the wombats is greater than the variance for the lifespan of the koala bears. That's our claim. That's H sub 1. H naught is that the two variances are equal. Our next step is we compute degrees of freedom of the numerator and degrees of freedom of the denominator. Degrees of freedom of the numerator is n sub 1 minus 1. That's 8 minus 1, which is 7. Degrees of freedom of the denominator is n sub 2 minus 1. That's going to be, yes, and that's also 8 minus 1, which is 7. Now we look up the critical value in table H. So let's turn to table H. In table H, keep in mind that the table is comprised of, let me just increase the table size. The table is comprised of several different alphas. So since this is a right-tail test, alpha's 0.05, the degrees of freedom of the numerator is 7. The degrees of freedom of the denominator is also 7. So at the intersection is the critical value, 3.79. So 3.79. We then compute the test point. It's S1 squared divided by S2 squared. So we take 3.3 square it divided by 1.6 squared. That gives us 4.25. We make our decision. 4.25 is in the critical region because it's greater than 3.79. Thus, we reject H naught, and there is enough evidence to support the claim. Number 2 is another F-test problem, but here we have some data. Instead of the summarized values, we have raw data, and we have to summarize our results. And I'll demonstrate how to do that shortly. For now, let's read the problem. It says, an educational researcher is testing the claim that there's a difference in the variances in the yearly cost between in-state students who attend Cal State universities and California community colleges. She collected the data that's provided below. The data is measured in US dollars. Test the claim using alpha 0.05. And as I mentioned, we have raw data. So step 1 is still the same. We state the claim. When you see the word difference, that means not equal to. So the claim is that variance 1 is not equal to variance 2. That's our claim. H naught obviously is that the two variances are equal. This is a two-tailed test. So our next step is to summarize the data. How I do that is I use Excel. Now other people can use calculators or whatever tool works best for you. Now in terms of computing the standard deviation, there's a built-in function that we will use. So it's called St. Diva. I type in equals St. Diva parentheses, and then I select the first batch of data values. Hit enter, and I already have preset the cell to round to 2 decimal places. And then next I just drag it over and it will automatically calculate the standard deviation. And I can also have Excel calculate each sample size. Just use the built-in function count. It will count all the data values. So there's 7, and then just drag it over and we get 7 as well. So we have the 2 standard deviations and we have the 2 sample sizes. And so that would be our next step, is to summarize the data, which I've done here. Next, we calculate degrees of freedom of the numerator. That's n1 minus 1, 7 minus 1 is 6. Degrees of freedom of the denominator is n2 minus 1. Once again, 7 minus 1 is 6. We look up the critical value in table H, but we have to be very careful because we don't have any left tails in the book that we use. So we need to divide alpha by 2 because we're only going to focus on the right tail. There's 2 tails, but we ignore the left tail. So whenever you have a 2-tailed test, you have to divide alpha by 2. That's going to give us a 0.025, so we will look up the critical value using 0.025 and the 2 degrees of freedom. So let's go to the page that contains 0.025. Degrees of freedom of the numerator is 6. Degrees of freedom of the denominator is 6. Look for the intersection, and we have 5.82 as our critical value. We calculate F. We take the first standard deviation squared divided by the second standard deviation squared. That's going to give us 106.11. And then we can see in the F distribution, here's the critical value. 106.11 is extremely large. It definitely falls in the critical region, so we reject H naught and we say there is enough evidence to support the claim. For number 3, we're going to use analysis of variance, or ANOVA, to perform the test. Let's read the problem. It says the weekly time spent studying by students for 3 different math classes is provided below. An educator wishes to test a claim that there's a difference in the average time spent studying for the classes. And this should be on a weekly basis, so let's write that in. On a weekly basis. The data is measured in hours. Test the educator's claim. So we have our 3 classes: topology, numerical analysis, complex analysis. We've documented the time spent by students studying for those classes. And since we're comparing 3 means, we have to use ANOVA, analysis of variance. So step 1 is we state the claim. So H naught is that all 3 means are equal. H sub 1 is at least 1 mean is different, and that's our claim. Now this is also an F test, so ANOVA is an F test. So we have to compute degrees of freedom of the numerator and degrees of freedom of the denominator. Degrees of freedom of the numerator is K minus 1. K is the number of categories. We have 3 different classes, so K is 3. So 3 minus 1 is 2. Degrees of freedom of the denominator is uppercase N minus K. Uppercase N is the total number of data values. So it's the total number of data values. And if we counted them, we have 1, 2, 3, 4, 5, 6. 6 times 3 is 18. So n is 18. So 18 minus k3 categories is 15. So we will use 2 and 15 along with the alpha to look up the critical value. Remember, the alpha is 0.05. So we turn to table H. We have to go to 0.05. Degrees of freedom of the numerator is 2. Degrees of freedom of the denominator is 15. We find that the critical value is 3.68. And then to calculate the test point, there is a formula or a couple of formulas you can use. My recommendation is to use either MS Excel or some other technology like a TI calculator, a graphing calculator that is. So I'm going to show you how to easily calculate this test point using Microsoft Excel. So in Microsoft Excel, there's a data ribbon that we have to access. So I have our data copied and pasted onto the spreadsheet. We click on data and we have to use what's called the data analysis tool. So we click on data analysis, make sure to select ANOVA single factor, press OK, and the input range is you select the entire chart. Make sure it's all selected. I like to put labels, so I click here, I type in the alpha 0.05. Now the output is where you want the two tables to output. There's two tables that will be outputted. And I'd like to select the cell that's a little distance away from the actual data set so it's not overwritten. And then just press OK. And we have an output. What matters to us in this output, really, all that matters for our purposes is this value right here. This is our F value. That's our test point. And so we can see that it's 5.27. Incidentally, the critical value is also generated. So for ANOVA, you can actually find the critical value and the test point. So we can see that 5.27 does fall into the critical region. We reject H0. We say there is enough evidence to support the claim. And for the last problem, once again, we do have another ANOVA problem. Let's read it. It says, 4 activities that people utilize to cope with stress are the following: exercising, playing video games, shopping, and watching TV. A researcher is studying the amount of time people spend on such activities and believe that there is an average difference in the amount of time spent on each activity. The data is measured in hours. Test the researcher's claim at alpha 0.05. So once again, the claim is that H sub 1 is at least one mean is different. That's our claim. H naught will be that we have 4 means that are the same because there's 4 categories. We have to calculate degrees of freedom of the numerator. That's k minus 1. 4 categories minus 1 is 3. Degrees of freedom of the denominator. Uppercase N is the total number of data values. That's 20. Minus the number of categories, 4, is going to give us 16. We then look up the critical value in table H using alpha 0.05. So we go to 3, degrees of freedom of the numerator is 3, all the way down to 16. And that's going to give us 3.24 as the critical value. Next, we have to calculate our test point. And I'm going to use Excel again to get this computed. So we click on our data ribbon, click on data analysis tool, select ANOVA single factor. Make sure we select our entire table. Alpha's 0.05, click on labels in the first row. Output range, let's output it over here. Press OK. What matters to us is only this F. Everything else is not important to us at this stage. All that matters is our F value, our test point, and that's going to give us 0.58. And that's going to fall short of our critical region. Critical value is 3.24, 0.58 falls in the non-critical region. So we write do not reject H0. There is not enough evidence to support the claim. Thanks for watching the video.